Okay, so if f of x is our basic graph, also referred to as the parent function, okay? If c is a positive real number, if we want to graph a transformation of f, where we're graphing f of x plus c, then f of x is shifted by how many units? C units. And is it vertically up or down? Vertically up. Okay, but what if I want to do f of x minus c? How does the transformation happen when you have a minus c? Go down c units. So it's the shifts by c units, but this time it's vertically down. So we call these two things post-operation. You add the c or you subtract the c after you do apply the operation f. Okay, so when you do the adding and subtracting post-operation, that always indicates vertical, right? In these next two, you're doing the plus or minus c pre-operation before you apply f, like before you square or before you square root. So when you have that f of x plus c, the graph of f of x is shifted how? Horizontally to the left, yeah. Horizontally left. That might have been surprising, right? You might have expected it to go right, but it goes left by c units. And much of the exercises we're trying to convince you of why that works that way. And that's why, like, we drew all those horizontal lines, and to get the same y value, you actually have to use an x value that's further left. What if we have f of x minus c? It goes right. Yep, horizontally right by c units. Okay. So these are our conclusions from day one. And then if I wanted to apply them in this one problem, I'll do it with you, and then I'll let you jump back in where you were. So I'm going to apply my conclusions here to the function, the square root of the quantity inside the pre-operation x minus 4, then post-operation plus 5. What's the original or parent graph or basic graph that this is a transformation of? Yes. Square root of x, yep. We call it f of x because it's a different function from g, but yeah. So my parent function or basic function or original function is just the square root of x. And what two transformations have occurred to create g of x? How do I transform the graph of f into the graph of g? Michelle? Yep. So we're going to shift f of x 4 units right. That's the minus 4 pre-operation, right? So that minus 4, because it's pre-operation, indicates horizontal, and those are always kind of the opposite of what you expect. So we go right 4 units, then up 5 units, right? The 5 is post-operation. That indicates vertical, and vertical shifts are exactly what you expect, right? Positive up, negative down. So for all the points on the original or the parent graph, what happens to every single x value? If you're going to shift 4 units right, how did all the x values change? They move right by 4, but what about the actual value? Like if the x value used to be 1, what is it now? 1 plus 4 would be 5, yeah. So all the x values increase by 4, right? If you're going to move right 4, the x value has to get bigger by 4. All right, and then how do my y values change? If all my y values go up 5, what happens to the actual numbers that are the y coordinates? They go up by 5. So if I'm going to draw the graphs of f and g by hand, I should make a little table for x, f of x. And I'll pick some values for x that I can take the square root of. So let's see, things I can take the square root of would be 0, 1, 4, 9, 16. And when I square root them, I get 0, 1, 2, 3, 4. So 0, 0, 1, 1, 4, 2, 9, 3, so that's 10, and 16, 4. Yeah. So there's my graph of f of x. And then if I want to graph g, I can just take each of those points that I plotted on f and move it right 4 and up 5, and I'll get the graph of g. So 0, 0 goes right 4 and up 5 and lands at 4, 5. 1, 1 goes right 4 and up 5, land there. And 4, 2, right? If I'm going to go right 4, my x coordinate gets 4 bigger. Up 5, my y coordinate gets 5 bigger. So I'm going to land at 8, 7. And then 9 plus 4 is 13. And 3 plus 5 is 8. And then I have 16 comma 4. Move that point right 4 and up 5. So I add 4 to 16 and I get 20. Add 5 to 4 and I get 9. So here's my new graph of the transformed function g of x. What's the domain of the function g? What x values does it live on? Four to infinity. So the domain of g, 4 to infinity. And what's the domain of f? Zero to infinity. How are those domains related? How are they related to each other and the transformation that we did? Increased by 4, yeah. So the initial x value increased by 4. Yeah. Infinity can't really increase by anything because it's not a number, just keeps going to infinity. Yeah, you wouldn't really write infinity plus 4 because that's just infinity. All right, let's look at the domain, the range of g and the range of f. I have a little typo here. So the range of f, range of g, the range of f. The smallest y value is 0 and it just gets bigger. So I have 0 to infinity. And then what's the range of g? 5 to infinity. And how are the 0 and the 5 related to the transformation we did? We shifted everything up 5, right? So my range used to start at 0, now it has to start at 5. All right, so I'm just going to leave you to go back to what you were doing. Mm-hmm.